Hello, my name is Emily Bender.
Hi, my name is Emily Neborowski.
Hello, my name is Alex Dover.
Hi, my name is Ben Stalman, and this is Team Indigo.
The Alternative Energy Vehicle Project was a project set up to create an AEV that would complete a certain number of operational objectives, being the most energy efficient as possible. The operational objectives were that the AEV would start at the distribution center and then move down a monorail track, stopping at the gate for 7 seconds. After stopping at the gate for 7 seconds, waiting for the gate to drop, the AEV would then move down to a loading dock where it would pick up a caboose. Upon picking up the caboose, the AEV would reverse direction and continue back down the monorail system, stopping again at the gate for 7 seconds, and then moving down to the distribution center where it originally started.
In the beginning of this project, the group individually came up with designs and then came together and compared and scored these designs against one another. From these designs, Alex Tober's design was selected and then moved forward with. It ranked the best scoring-wise, but ultimately sort of shifted, especially once we started beginning testing. We sort of stayed testing with the same model and tried to figure out and focus on more of the programming aspects before we got into the design aspects. The team had quite a bit of kind of conflict with what they wanted to be for the final design. There were a lot of ideas brought to the table and not all of them were acted through with. Mainly an additional servo motor was wanted by the team, but how it was wanted was different across the team.
AEV features a custom printed part that we designed in SolidWorks and printed with the MakerBots. It has a custom printed body with a small little wedge thing coming out on the bottom that we can attach a magnetic thing to so it can grab onto any caboose that we need. The Arduino and battery is on the side of the AEV, and the hanger fits into a little slot on the AEV's body to be able to fit better and not fall off. We have horizontal wings which are perpendicular to the main body of the AEV with propellers in the pusher configuration to help propel the AEV forward. We also have, which is unique to our group, a servo brake and motor on our AEV itself. The servo brake was used to help control the AEV in stopping, and the motor actually grabs onto the wire track that the AEV runs on and is used to help stop the AEV so it doesn't go forward or backwards if you don't want it to. We used a servo library in our programming strategy in order to better control our AEV and control distances and times better than had we not.
3D printing parts were necessary in order to achieve a certain compactness with the design as well as to reduce our weight in the AEV. 3D printing the servo arm was necessary because it was hard to find a part that would meet the requirements needed for the servo arm. Additionally, 3D printing the part allowed us to have the brake meet the curvature of the track, which allowed us to brake with less pressure and with more efficiency.
The group was extremely satisfied with how the AEV turned out and completed the operational objectives with a perfect score.
Is there anything that you would change, anything the group would change to the AEV?
The group would make some slight modifications to the AEV if possible. We would potentially try to print other 3D parts to make the AEV overall lighter in design. Another change that we would probably make is to the coating of the AEV, trying to make it coast for as long a period of time because of the brake, allowing the motors not to need to reverse to slow it down. Because the longer it coasts, the less energy it's spent in accelerating or maintaining speed.
The main goal of the AEV project was to create an alternative energy vehicle, an AEV, that was able to consistently meet some operational objectives and be as energy efficient as possible.
Would you say this goal was achieved?
I would say it was mostly achieved. The AEV was able to meet all of its objectives consistently every single time that we tested it. Every single run that we did had a perfect score. However, it wasn't as energy efficient as we would have liked. It consumed 216 joules on its best run. We would have liked it to be under 200, but we figured this was still relatively good for our AEV.
This has been Team Indigo. Thank you for your time. is Emily sound so irritating
I wonder.
behind the scenes?
That was better.
That was good.